Hello, my name is Jorge Prado.
Hi everyone, my name is Laiba.
Hi, my name is Anna.
We are here to talk to you about DNA digital data storage. Every day, we're producing thousands and thousands of data. Imagine that we can save all the data in the world in 3 buckets of pain. It's mind-blowing that we can do this with DNA digital data storage. We are here to inform you about this topic and how important and beneficial it's going to be for our future. So, what is DNA digital data storage? In simple terms, we encode and decode the binary language into DNA's base sequence. The DNA bases are adenine, cytosine, guanine, and thymine. The DNA base sequence are artificial, which means that it's produced by human beings. DNA digital data storage is much more denser than the storage systems we have now, because eventually we're not going to have any physical space to store all our data.
Today I will be talking about how DNA digital storage works and who invented it.
Storing digital data in DNA. This is how the process works. First, the digital data is converted from zeros and ones to the 4 building blocks of DNA: A, C, G, and T. 0, 0 becomes A, 0, 1 becomes G, 1, 0 becomes C, and 1, 1 becomes T. Twist bioscience then writes the sequence of DNA. DNA can be stored for thousands of years and is decoded when needed. DNA, nature's preferred storage media. The future of digital data storage.
So all our data is represented by binary codes, zeros and ones, and DNA is represented by A's, C's, G's, and T's, which are adenine, cytosine, guanine, and thymine. So the first step is to transform the digital data files into the binary language in zeros and ones. Then the binary code will be encoded to A equals 0, 0, C equals 0, 1, G equals 1, 0, and T equals 1, 1. After the transformation from binary code to the new nucleobase code with only A's, C's, G's, and T's, the synthesis will begin creating the artificial DNA. And once it's in DNA form, this can easily be stored because the digital DNA is much denser than the physical digital files. The great thing about DNA is that it can be stored for years without causing any damage to the DNA, unlike the physical digital storage, which over time will damage and it will be damaged and destroyed. If anyone would like to have access to information of DNA, first the DNA must go through the process of sequencing back to A's, C's, G's, and T's, then decoded to the binary code so it can be read back to the digital files. Now I will be talking about who invented the digital storage. So the idea of calculations of the possibility of recording, storage, and retrieval of information on synthesized DNA molecules was from the Soviet physicist Mikhail Samoylovich Neyman in 1964. However, one of the first actual uses of DNA digital storage was in 1986 by MIT researcher Joe Davis, titled Microvenus. Davis transformed a graphic icon from the ancient Germanic rune into a simple binary code. Then Davis converted the binary code into a DNA sequence that was inserted into living E. coli cells. Thank you.
Hi, my name is Anna, and I'm going to start by talking about prices. Well, the cost of encoding 1 megabyte is expected to be around $12,400. The decoding of the DNA sequence base costs around $220. It is currently quite expensive. However, the cost of DNA digital data storage will decrease. DNA storage is becoming more marketable and accessible as technology progresses. Although DNA digital data storage is not as popular as it once was, we will ultimately run out of physical space as we create so much data every day. DNA digital data storage offers both advantages and disadvantages. Some of the advantages of storing digital data in DNA are that even without any care or power supply, DNA can remain stable for a long time. Also, because DNA is smaller and lighter, it is easier to store and transfer. In addition to that, in the future, physical storage systems will be completely outdated. Regarding the disadvantages of storing digital data in DNA, as previously mentioned, DNA synthesis is expensive, about 12,400 per megabyte. Another thing is, data is read slowly because it must be retrieved first. And lastly, DNA cannot be updated without restarting the synthesis. The ethical concerns include who will have access to all of this information and who will be in charge of the DNA sequences. The DNA is incredibly little in both size and weight, and it might be easily misplaced or stolen from those who possess it. If all of our data falls into the wrong hands, private companies or people on the deep or dark web will profit from our public records. At the end of the day, companies must be held accountable for their activities, and they must think ethically and respect everyone's choices when it comes to our data.
In conclusion, I believe that DNA digital data storage is an excellent alternative answer because DNA can be transmitted from one generation to another. We're moving in a direction where we're not going to have any physical space left to store our data. DNA digital storage is a great invention despite the disadvantages we discussed. I hope our presentation was informative to you. Thank you for listening. Here are my references for my presentation. And are there any questions?